And final panelist to give a brief presentation, and then we'll open it up for Q&A. Please write down your questions, and Dave, should they give them to you? There'll be runners to get your questions. Keep thinking about that. Guy with the nice white shirt there and the red tie, he'll take care of you. All right, let me introduce John Koster, Vice President, Enterprise Solutions at Skanska. John's a recognized expert in successfully leading complex IT programs and critical operations across a wide range of industries. Prior to joining Skanska, he held senior management positions responsible for planning, building, and operating large enterprise data centers throughout the United States, Europe, and Asia. In his role leading the data center strategy at Microsoft, he was responsible for strategic planning, delivery, and operations of Microsoft's worldwide mission-critical IT data center approach for over 8 years. Now, it turns out that was right before they bought Pi. Pi would have made his life a lot easier, but still he was able to be successful. In support of Microsoft's Enterprise Risk Management Initiative, John led the formation of Microsoft's Business Continuity Management Framework for IT, which ensured appropriate safeguards and compliance to address increasing demands by investors, customers, and regulatory agencies. As a senior project manager for Engineering News and Engineering News Record Top 400 contractor for over 10 years, John had executive responsibility for client relations through project delivery of large and complex public and private projects, including commercial, manufacturing, healthcare, education, energy, ports, telecommunications, and high tech. Please welcome John.
Where's the button here? Right there. Good morning, everyone. I realize that I am the only one standing between you and lunch. No, there's a panel. Oh, there is a panel. Oh, okay, that's good. That's good. So I'm the only one between now and the panel. The green button? It's the right button. Thank you. Oh, right of the green. Thank you. They didn't. So this morning, one of the nice things about coming in after these folks is they've already covered a lot of the material I was going to cover, so I will be able to shorten it up a bit, I think, and get right to some of the key points. Some of you don't know who Skanska is, so I'll give you a brief overview, some of the trends that are happening in data centers and IT, and then some of the obstacles that we see with our clients in the industry in general, and then how we use some of the tools, the techniques, the methodologies that we've been talking about this morning to help improve that, some new delivery models, and how we harness that data. Where does it go? So Skanska at a glance. So we are a we're a 124-year-old construction company that's global. We're usually in the top 10 of the world, depending on who's keeping score. We are a publicly traded company. We're signatory to the UN Compact. That's a very big deal for us because it really ties into the 10 principles of the UN Compact, which is about human rights and the environment and social equity, and also ISO 14001, which is about ecology. And Beth Hyder is going to be speaking later about that. And so that's a big part of who we are as a company. What do we build? We do a lot of things. We do more than build. We'll actually develop and take an at-risk position to build power plants or large industrial complexes. We'll do the entire thing, and we'll take it all the way through operations. And as an at-risk, the ability to do that, to say, we're going to build something to a particular performance guarantee, you have to understand all of the levers in order to know how to take that risk. Part of what we do is manufacture components. Buildings these days are more assembled than constructed. And the reason you can do that has to do with the 4 elements of scope, what you're building, the cost, the quality, and the schedule. And to be able to modularize things that we build helps to improve that, and that's what's able to give that supply chain control over the final delivery process. And we do it through modeling, through building information system modeling, 3D visualization, the same way you manufacture airplanes, automobiles. We do that with buildings as well. So data centers. I want to talk about that for just a minute. 15 years ago, there was no such thing as the data center industry. Data centers were essentially computer rooms that were sitting on the appendages of office buildings of very large companies, governments, and maybe a few universities who needed some mainframes. And then, as you may recall, for those who were around then, in the middle of the 1990s, data centers started to evolve as the internet promise evolved, and actually millions of square feet of data centers were built, justified or otherwise. And then right after the dot-com bust, there was a lot of distressed properties, but there was a lot of data centers that actually were repurposed into other things. But eventually, Web 2.0 took off, and data centers became an industry. But data centers had been large buildings with large power plants and large cooling plants. And between 2000 and 2005, depending on which report you read, the amount of energy that was used to power data centers doubled and became 2% of the total annual use of energy, which by sector is a big component with the United States. The industry got together, created different organizations like the Green Grid, and said, we need to come up with a way to figure out how to be more efficient. Because, in fact, most data centers, for every watt that went in, sometimes another watt all the way to another 3 to 5 watts of energy were being used just for process cooling. We had to figure out a way to make it more efficient. So, what has driven the IT growth? Well, we talked a lot about it today. Every time you turn around, there's a new thing. Does everybody remember when the iPhone first came out? That was a long time ago, wasn't it? Does anybody have any idea how many applications were available day one in 2007 when the iPhone came out? Any guesses? Come on.
0.
No! Apple would never do that. How many applications came out? No, 500. There were 500 applications day one. If you stood in line and got your first iPhone, you could download 500 applications. Within 36 months, can anybody tell me how many applications were available? 300,000. 300,000 applications. I haven't kept track because after 3 years, like, who cares, right? But I was thinking about when I took the taxi cab here to my hotel from the airport, and I asked the guy if he could take a credit card, and he said, sure, and he pulled out his iPhone, and he stuck in a square U, and he swiped my card, which was scary, but I've used it before, so I know it's safe. But I got the email right there as I'm sitting in the cab. I get the email from U-Square. It says, here's your tab, here's your receipt, bam, right? Well, that's an application. And where do these things sit? Well, it's not just free. You know, everything Anish talked about. Oh, we're doing this, we're doing that. Where do those things sit? They're not sitting in your handheld device. They're sitting in a data center somewhere, right? And that data center has to have some level of what? Cost, capacity, and risk and SLAs associated with that. It isn't free. Consumer appetite. I just put technology enablement because as the kind of innovation we were talking about this morning, the amazing advances are putting huge pressures on the information infrastructure, and that's what data centers are, and they continue to grow. According to some reports, and after I'm through with my talk, maybe this will become self-evident, some reports forecast that by 2015, the annual market for data centers will be $41 billion. And I was thinking, $41 billion. This data was taken from surveys, and it's not real hard data. How do you get within why couldn't it be 40 billion? But no, it's 41 billion. That gives it a sense that it's accurate, right? So statistics are funny, and the way that we gather the data to report on those statistics are equally funny. Infrastructure automation, the smart grid, everything that's happening, even with water, wastewater, energy, and then regulatory compliance. Every time you turn around, healthcare, whatever, oh, we need more backup, we need more storage, we need more security. Well, when you add more security, that adds infrastructure, and that adds more data center space. So the growth continues to forecast, but really there's no central repository of data. In fact, even the people you ask. I was in operations for 10 years at Microsoft and at Savvis Communications. If you sent me a survey and said, what did I think my forecast was going to be, I'd give you a wet finger in the wind, and that would go into somebody's report along with everybody else's, and that would be sort of the market data that would drive growth. We don't have good data, and so herein lies the point. So the stewards of the old computer room have become the industry leaders in the data center industry. And this is what they want. This is what our clients want. They want the lowest cost per unit. I have customers that say, I want to know what my cost per click is. And IBM actually did a study that said that the cost of an avatar in another life was more of a carbon footprint than a real person living in Brazil. I don't know how they did that, but they did. IBM did that. So, lowest risk. Now, that means a lot of things. It doesn't just mean the probability of an unintended outage, although in the data center parlance, that's typically what they care about. It could be any kind of risk. It could be the fact that you've got a data center that's so full that your company wants to put out a new product, and there's market timing, and you can't roll it out because you don't have enough capacity. You miss that market timing, boom, it hits you with unrecoverable losses. Or it could be security risk, information security risk. There's lots of risk that is put to that, and there's ways to ameliorate that. Highest asset utilization. Used to be data centers, you built a big building, you stuck a lot of power and cooling so you could accommodate that. It's become so expensive to have unutilized capacity that now people are looking and saying, how can I drive that cost down? And then, of course, just-in-time capacity. So when you think about these large, I mean, a typical data center is somewhere between $50 to $100 million of an investment of a company or an institution to put in. It's not a small capital investment, and then the operations for that is also substantial. And so there's getting a lot of laser beam targets by the financial parts of companies to say, how can you achieve these? So what are the obstacles? We have been talking about them all morning. The silos of different things, and I love the walks, the hacks, and the troops, because that's sort of what we have within our business of trying to deliver innovative solutions to our customers. We've got a very fragmented supply chain. We get parts and pieces from all over. I mentioned that building buildings is more about assembling them, and so the people or the companies that know the most about any building, whether it's a high-rise or a shopping center, is not the architect or the engineers or the developer. It's the specialty subcontractors and the suppliers who create these prepackaged things that basically get assembled. They know the best. And that's where the embedded intelligence is. And that data sits typically, we can talk very high level, but when you're down at the boots on the ground level delivering a project, these people come in, they plug their stuff in, they give you maybe some digital documents that sit in a PDF format, and you have volumes of this, and that data is completely unavailable to anybody after the fact. It gets put in, it's done, and there's no intelligence at all. The organization for a data center, where the IT group is the customer, is a problem, and it's almost as big as the governmental challenges that we were talking about earlier this morning. Here's an example. When you're trying to build an IT facility of any kind, and it doesn't matter who it's with, you've got the real estate people that are responsible for procurement, and they take a look at what's it going to cost me to design and construct this. You've got the facility management folks after the fact, and these are all, I don't know if you can read all those, but they are all the different sort of stakeholders that all have a very different perspective on what's successful for them. On the IT side, that gets even more sort of fragmented and stratified. The business solutions people are the ones that sit down with your business group in law and say or in finance and say, what business do you have, and do we build or do we buy? Do we go to the cloud? What's the best solution for you? Once they've got the best solution, it goes to the IT architecture folks that say, do we build this level of resiliency, this kind of capacity, and whatever, and then they pass the baton down to the engineering folks that build or buy or outsource any combination of applications, platforms, storage, whatever, and information security and compliance. That gets thrown over to the wall to the real estate folks. That's what they build. But none of those decisions are made in concert. They're just passed off. They're these deep, deep silos. Sometimes it's helpful to have sort of an ontological model, and I've built this, and it sort of sometimes helps both inform and confuse people. But when you think about IT, which is driving, we talked a lot about the kinds of applications that get thrown into this infrastructure. You've got sort of, what's our business need? That's at the core of everything. What does success look like? And the goals are, we've got strategic goals, whatever that might be. If you're Amazon, it's going to be different than if you're the U.S. government. You've got the risk, and I talked about the range of those. You've got capacity, and that could be space, or it could be power, it could be cooling. And those ratios continue to change as new technologies come out for virtualization. People like Google and Microsoft, they have a homogeneous environment. They're able to build it from the inside out. But everyone else in the world who has a large data center is living with very heterogeneous sort of platforms that live all by themselves, and so you're not able to control all of the capacity forecasting. Legal and financial, environmental. What does your footprint look like? Some people think about energy, but for every watt of energy, there's a corresponding use of water, and water is the new carbon, right? I mean, there's a shortage of water, even though there's flooding in Vermont. The places where they need it, they don't have it. Then you've got all of the financial sides and the SLAs, which are service level agreements. So those are goals, and if you were to take all of the stakeholders, the financial, the real estate, the IT people, and you were to sit them around the table, they would all say, yep, those are the things, and they would all say there were different things about them. But decisions have to be made. So from a pure decision science about location, architecture, what do we put in? Who are the end users? What are the concerns of different constituents? That's kind of the challenge. That is the big challenge of any large organization. It's the challenge of every CIO. That's their job. So we've created the model and we say, well, if we take, this is not working, we take scalability, for example, one decision about scalability, how big do we do it, impacts your CapEx. And every corresponding decision that's made then impacts some other element of it. And unless you're able to model it, you can't really make an informed decision, because you'll be building things and you'll be running things in a way which may or may not be meeting the needs of the most important aspects of your business or enterprise. Last arrows. So, what have we done? Well, we found that the strength of it is actually in Pi, and if we didn't have Pi, we couldn't do this. This is absolutely the foundation. We identify the data boundaries. What are all the different components that we need to grab? We've got to grab that dynamic data. We've got to grab the time series, the way that it's used. And we've got to be able to pull it into an environment where we just capture it is the first thing. And then what we do, and that jumped ahead, we basically create a data bus. We grab that together, all these abstracted layers of data, these silos of data, and we pull it into into the Pi environment. We use the asset framework. We layer on top of that the relational database of our fixed assets, which may change through some other source or may be tied to Pi. And then we layer analytics and workflow and visualization and simulation on the top of it. So what we have for our data center clients and now our healthcare clients, because we're moving into healthcare, and I think that almost any industry you can apply this principle to. You create a common data source in which you've now got a sort of an ontological data model where it's all there, and then people who have different interests can access that data, but it's the same data source. The big challenge is trustworthy data. Everyone we talk to, all of our clients, when they see our cool dashboards, they go, yeah, but do we trust what's underneath it? And the truth is, we don't in most cases, because the source of that data is unreliable. So by using the Pi data, we're able to stand by. It's got full lineage. We can go down and see what's the source of that. How do we know that's true? And it's completely auditable. And that alone is probably the single most important thing that enables us to do what we do. Otherwise, it's just really cool interfaces and cool manipulation and business intelligence. The other thing that's important is we have to work with our supply chain. So all of the different components within that stack that I showed you, we've got to build the intelligence into it. So the embedded chips, all the things that we put into our different systems, and I'd love to go into any one of these systems, and I could if we had time, but gives us that reference point where we can pull that data in. When we build our data centers for our clients or for ourselves, we have to make sure that all of the intelligence components are embedded in there, so I know what data I need to grab so that I can see, and I'll show you in a second what we do with it, I hope. So you've seen these dashboards. They're pretty straightforward. What this does is, if you think about this decision model, our operators can take a look at almost any kind of corollary data. You can see causal relationship. It's a great discovery tool. What happens when we see our load begin to increase? What does that do to our system behavior? What does it do we have GIS data, global spatial system data that we can use, climate data that we can say, how is our system performing in the context of its environment? Lets our operators do what they need to do, make the adjustments they need to make. Risk, as I mentioned before, is a really big deal. I'm going to just focus in just for a second on this because it's so important. With data center owners, in the network and compute industry, they talk about a number of nines, 5 nines, 6 nines. There's 8,600 hours in a year or so, and if you take 99.9999, that's 6 nines. That's all but 30 seconds of uptime, and that's okay if you want dial tone or if you want availability of an application. But with power and cooling systems in a data center, if you have a single 20 millisecond outage, that'll take your systems to its knees, and it may take it down for days. One company that I was with, they had a 1-second outage, and it took down their SAP, their financial services, down for 3 days while they had to rebuild things, and they almost didn't meet their Sarbanes-Oxley requirements for filings. And that was a single outage. So for data center operators, the facilities guys, they care about mean time between failure. So if you're familiar with reliability engineering, those are pretty standard practices. You can do statistical analysis on architecture and say, if we build it with this level of resiliency, you'll get this level of mean time between failure. But if we have a tool that can capture all of the things that are in that statistical model to pull up some empirical data, that's a better predictor of what we need to spend our money in. Because at the end of the day, what a data center operator needs to know is, every year, budget time comes, what do I spend my money in? What do I do in terms of people, processes, and technologies to reduce my risk, to mitigate that MTBF? So over here on the right, what we've done for one of our clients is we took the types of alarms. So you have an alarm in a data center, something that's maybe an incidental alarm, that's a class 1. A class 5 is a severe alarm, right? So we start collecting data on alarms by type and class, and what does that give us? It gives us sort of a profile of what the probability is of a failure. Now, if we start to correlate activity, what are we doing before, during, and around those things? We can start to actually pull data out that allows us to make informed decisions about where to invest that money. If I take, for example, and say, I'm noticing that on a, come on. If I use my building information model, that's a 3D representation of a data center. If I know, for example, on that air conditioning unit on the side, if I lose my cooling and that temperature starts to go up, my IT infrastructure is at risk. So if I say, I've noticed that I'm having these kinds of operational behavioral failures, I can pull up a database of all of those types and see how they're performing elsewhere within my environment. If I've got a large portfolio, I can start to pinpoint in problem areas and make really, really good decisions at an operational level about how my systems are performing and how to maximize my investment and know what to do. This is really good business stuff. It makes it meaningful. You can stay up in the high theory stuff about decision modeling and decision science, and at the end of the day, it'll be kind of a, the executives will say, well, let's go this direction, and then we'll see if they're right or not. But at the end of the day, the guys that are on the ground, the people that need to make real solid decisions need this kind of data, and we're finding that it becomes valuable for that reason. Going up the stack, this is the executive dashboard that we built for one client where here's a portfolio of their data centers across the country, and the stoplight report is standard. Pay attention to the red bubbles and start to worry about the yellow bubbles, right? But what does that mean? Each one of those, you can click in and look down and say, I care about my capacity, I care about my cost, I care about my risk. What are the drivers? What data am I using to give me these incidents, and are they reliable? So what you've got is a single data source, but it's available to people with lots of different interests, lots of different stakeholders, all of whom can act upon it with the knowledge that it's trustworthy. And that's the platform that we build our data centers on. I know it's pretty high level, but that's kind of it in a nutshell. I liked a quote by Peter Drucker. And I think sometimes when I first read that, I thought it makes it sound like management is kind of like a given and leadership is what you really need. But in this case here, I think that when you've got the common data bus that we're able to really harness using Pi, you can do both. It helps us do both well. So thank you very much.